All right, so get ready because we're going to dive into a career that's building the future.
Okay.
We're talking about mechatronics engineering technicians.
Right.
You've sent us like a ton of info on this,
Yeah.
guide salary stuff, interview tips. It seems like somebody has robots on the brain.
It does seem that way, and you've provided some great resources to break this all down.
Yeah.
You know, when most people hear mechatronics,
Mhm.
they probably think of like some crazy sci-fi movie, but this field
Yeah.
is anything but fiction.
This isn't about like the Terminator coming to get us.
Right.
It's about the really smart people behind the scenes making these robots do something useful.
Exactly.
So what is like a day in the life
Yeah.
of a mechatronics engineering technician?
Sure.
What do they actually do? They're not just like building robots in their basement, are they?
Well, having a personal project cave never hurts.
Right.
But you're right. It's way more than just that.
Okay.
These technicians are really like the bridge between the mechanical, the electrical, and the computer engineering worlds.
Mm.
They're the ones who build the prototypes,
Mm-hmm.
test them,
Mm-hmm.
and make sure these really complex systems actually function in the real world.
Okay, so it's like hands-on, but you need some serious brain power.
Yes, definitely.
What I thought was so interesting was this guide mentioned problem solving as like the most important skill.
Absolutely, because these systems are incredibly intricate.
Yeah.
Imagine you're trying to troubleshoot like a robotic arm on a manufacturing line.
Right.
You've got the mechanical gears, the motors, the electrical circuits,
Mm-hmm.
and then the software that's controlling all of it.
Oh my God.
It's like solving a puzzle, but with like a million different layers.
So you've got to have those critical thinking skills to figure out what's going wrong.
Exactly.
And I bet good old-fashioned reading comprehension comes in handy
Oh, absolutely.
with all those technical manuals.
All those manuals, yeah. And speaking of skills, the guide also really emphasizes that hands-on experience.
Because you can have a degree, but can you actually use it? There's that saying, like, in theory and practice are the same, but in practice they're not.
Exactly. And that's very true here.
Yeah.
They even recommend building up like a portfolio of your own projects.
Okay.
Maybe you tinkered with robotics in high school or designed like a simple automated system.
Yeah.
All those experiences are so valuable.
So it's like show, don't tell.
Exactly.
I love that. So what are we talking about here? Like building a robotic dog
Okay.
that can go fetch you your slippers.
Or a robot dog. That would be impressive.
Right.
But even something simpler than that,
Yeah.
like an automatic plant watering system using sensors
Mm-hmm.
and a microcontroller
Okay.
that shows you understand those core concepts.
Yeah. It shows that you have the initiative to figure it out on your own.
Exactly.
That's huge. Now, the guide also dives into something called additive manufacturing.
Yes.
Can you explain that to me?
Sure.
Because that sounds very Star Trek-y to me.
It does sound very futuristic.
Okay.
But it's becoming much more common. It's essentially a fancy way of saying 3D printing.
Okay, so like those 3D printers that are becoming popular now.
Exactly.
Yeah.
Instead of like traditional manufacturing where you cut away material,
Mm-hmm.
additive manufacturing builds an object layer by layer
Oh, wow.
from a digital design.
Yeah, makes total sense.
Right.
And I bet that's super helpful for these guys for prototyping
Absolutely.
and building those custom parts.
Exactly.
Yeah.
Knowing how to design and print parts on the fly
Yeah.
is such a valuable skill in this field.
Right.
Allows for faster iteration and more customized solutions.
That's awesome. So let's say you've got the skills, you've got the experience, maybe even a garage full of half-built robots.
Sure.
What's the actual career path look like?
Okay.
You don't just jump right into building spaceships, do you?
Not right away, no.
Okay.
But you're right, it is a progression.
Okay.
The guide outlines these 4 main stages.
Mm-hmm.
You start with the entry level, and you can move all the way up to a senior technician.
Oh.
And each stage comes with more responsibility,
Yeah.
more complex projects,
Yeah.
and of course, a higher earning potential.
Let's unpack those stages a little bit.
Yeah.
What does that entry-level position actually entail? So you're fresh out of school, you're ready to go, you're ready to build some robots.
Yeah.
What does that entry-level job actually look like?
So at the entry level, you're definitely diving right in.
Okay.
But you've got kind of a safety net.
Okay.
You're mostly assisting more experienced technicians,
Okay.
really getting a feel for real-world projects,
Yeah.
learning how everything works in the industry.
So you're not expected to come in on day one and build like a self-driving car?
No, not at all.
Okay.
It's much more about absorbing knowledge, like a sponge.
Yeah.
You're working on very specific tasks,
Okay.
maybe troubleshooting a faulty sensor on a machine, or, helping to assemble a prototype.
Mm-hmm.
But it's all about building those really important foundational skills.
Learning by doing, basically, which is great for a hands-on field like this.
Absolutely.
So what's like the next step up from there?
So once you've got, a bit of experience under your belt, you would typically move into like a junior technician kind of role.
Okay.
And that's where you start to take on a little more responsibility.
Right.
You might even be developing like smaller mechatronic devices or components,
Okay.
but more independently.
So you're trusted to do a little bit more on your own.
Exactly.
But still with that guidance.
Yeah, you always have people to ask questions to.
Yeah, for sure.
Which is really important.
So when you're ready for like the big leagues, then what happens?
Then you're talking about like the intermediate technician role.
Okay.
And here you're not just working on like pieces of things anymore. You're leading the development of entire mechatronic devices, applications.
Okay.
This is where you might be designing like the control system for an automated guided vehicle.
Oh, wow.
Or like optimizing the performance of a robotic welding cell.
So the projects are getting way more complex.
Oh, absolutely. Much more challenging.
And it seems like at that point, like communication is almost as important as your technical skills.
It really is.
Yeah.
Because you're collaborating so much more with engineers, with other technicians,
Right.
even clients sometimes, to make sure that everyone is on the same page.
That makes sense.
And it's not just about the technology itself anymore either.
Yeah.
It's about understanding like the needs and the goals of the entire project.
You're not just building something just to build it.
Exactly.
It has to have a purpose.
It has to function in the real world.
So what's like the pinnacle then of this whole career path?
Okay.
What does it mean to be like a senior mechatronics engineering technician?
Okay, so reaching that senior technician level, that's like you're the Jedi Master of mechatronics, basically.
Okay.
You've got years and years of experience under your belt.
Right.
You have this deep well of knowledge.
Yeah.
And you're the one leading the charge on like the most complex projects.
Yeah.
So think like overseeing the design and implementation of a fully automated production line in a factory.
Oh, wow.
Or you might even be developing brand new mechatronic systems from scratch.
So you're like the go-to expert.
Pretty much.
If there's a problem, you're the one that everyone else goes to.
You're the problem solver.
To figure it out.
Exactly. And that's a lot of responsibility.
I bet.
But it's also incredibly satisfying.
Yeah.
You're mentoring the junior technicians. You're really pushing the boundaries of what's possible with this technology.
Right.
And you're shaping the future.
Now, speaking of the future and shaping it,
yeah.
I know we talked about like the salary a little bit before.
Right.
But I'm guessing that those senior level folks are making bank.
Well,
right? Like, what's the financial upside of moving up this career ladder?
It's definitely a major draw for a lot of people.
Yeah.
I mean, according to the Bureau of Labor Statistics, like the median annual salary for this job was around $58,240.
Okay.
Back in 2020. But that's really just a starting point.
So you're saying with experience, with specialized skills.
Exactly.
At those higher level positions, that number can go way up.
Oh, for sure. Especially senior technicians.
Okay.
Those with expertise in really high demand industries, like robotics and automation, they can earn well into six figures.
Okay.
And the best part is,
yeah,
with the demand for these skills constantly growing,
right,
those salaries are only going to go up.
So it's good for job security as well.
Exactly.
Now, it's not all about the money, though, right?
No, of course not.
There's got to be like a real sense of accomplishment that comes with this.
Absolutely. It's incredibly rewarding.
Yeah.
To see a project go from like an idea on a piece of paper to a real working system out in the world.
Right.
Whether you're designing like a robotic arm that can assist with surgery, or you're optimizing a manufacturing process to make it more efficient. There's a real tangible impact.
There's a purpose.
Yeah.
It's not just about the robots.
Right.
It's about how this technology can change the world.
Exactly. It's that bigger picture.
And that brings us to something I think is very important.
Oh, okay.
It's the ethical considerations
Yeah.
of all of this.
For sure.
Because that's something we haven't really touched on too much yet. So when we talk about the ethics of automation, it does feel very like, oh no, the robots are coming to take our jobs.
Right. It's where the sci-fi starts to come in.
Yeah, exactly.
And I think it's a really understandable concern that people have.
Yeah.
We're talking about machines making decisions that could impact people's jobs.
Right.
Safety concerns if something goes wrong.
And the guide actually mentions that a lot too.
It doesn't shy away from those bigger questions.
Which I think is good because ignoring them isn't going to make them go away.
Exactly.
So what is like the role then of the mechatronics engineering technician
Okay.
in all of this? Because it's not like they're the ones writing the code for a self-driving car to decide what to do if it's about to hit somebody.
Right. They're not usually the ones programming like the AI itself,
Okay.
but they are the ones building, testing, and maintaining those systems that the AI is interacting with.
Okay.
So that means thinking very critically about, potential points of failure,
Okay.
safety protocols.
Mm-hmm. It's a lot of responsibility.
It is a huge responsibility.
It's like a moral compass almost.
Yeah, there's a bit of a moral compass there.
On top of your toolbox?
Yeah, sure.
Can you give me like a real-world example of where those lines might get a little blurry?
Sure. So let's say you're working on a project where you're trying to automate part of a factory.
Okay.
And it's tempting to think, okay, well, if we automate this, it's going to be so much more efficient.
Right.
But what if that means that, several people are going to lose their jobs?
Right.
Now, the technician isn't the one making that final decision.
Right.
But they can be part of the conversation.
Mm-hmm. And raise those concerns.
Exactly.
Potentially.
Just other designs, maybe. That might, prioritize the human element a little bit more.
Being aware of the bigger picture.
Absolutely.
Okay, so using your knowledge to advocate for responsible development of this technology.
And that's only going to get more and more important as we move forward.
Right.
And these systems become even more integrated into our lives.
Like we talk about like medical robots assisting with surgery.
Exactly.
Like that's
high stakes.
Yeah, that's life or death.
Right. So the technician's job there is so important to make sure that everything is precise and safe.
So it's not just about building the robots, it's about building them responsibly.
Absolutely.
And ethically, and really thinking about the impact that's going to have on people.
Yeah. And that's a lot to think about.
It is, but it's also...
It's really important.
It's what can make this job so rewarding.
Exactly. Because you're not just building a machine.
Right.
You're shaping the future.
And speaking of shaping the future, for anybody listening who's like, yeah, this is me, I want to do this. What's that first step?
Yeah.
What can people do right now today to kind of dip their toes into this world?
Well, the great thing is you don't need a fancy lab or anything to get started.
Okay.
I mean, the guide even emphasizes those personal projects, like we were talking about.
Like build something.
Build something exactly.
Yeah.
Like a little robot arm, a sensor-activated device. Even if it's just tinkering around with like an Arduino kit.
Yeah.
It gets you thinking in that way.
It's all about like getting your hands dirty.
Yes.
And figuring it out.
Exactly. And it's okay if you make mistakes.
Right. Trial and error.
That's how you learn.
Exactly. And then beyond that, like find your people.
Find your people.
Right.
I mean, there's online forums, robotics clubs.
Yeah.
Even like maker spaces in your local community.
It's a great way to meet people who have similar interests.
Exactly. And you can all learn from each other.
Yeah. Bounce ideas off each other.
Get inspired by what's possible.
So find your people, build some cool stuff, and you're on your way to being a mechatronics engineering technician.
That's it.
That's awesome. Well, I think this has been a really fascinating deep dive.
It has.
I've learned a lot.
Me too.
Thanks for joining us.
Thanks for having me.
And we will catch you guys next time for another one.